Last class we talked about degree measures, and today we're going to talk about radian measures. So the definition of a radian measure is that 1 radian is the measure of a central angle that intercepts an arc S equal in length to the radius r of the circle. So think about that on a circle. If I take a circle and I mark a radius, so let's say from here to here, and I try to rotate around the outside of this circle. So let's say that this radius is equal to 10. And if I can measure 10 units around the outside of this circle, maybe about there, then I have completed 1 radian measure. So this rotation is equal to 1 radian. You're pretty used to doing it with degrees. If I asked you to show me a rotation of 1 degrees, then anywhere that you start on your circle, it would be a very small amount. It would be like really, really small, because it would be 1/360th of the circle. So this would be 1 degree. Now, there are 3 ways for measuring or representing the measure of an angle. And so one way is to do it in degrees. So if you start with an XY coordinate plane, and you look at an angle starting in standard position, and you start at the positive x-axis, that would represent 0 degrees. And then your first right angle would represent 90. And then to the negative x-axis would represent 180 degrees. And then another 90 degrees would be 270. And a complete revolution would be 360. All right, now if you're asked to do it in terms of pi, think about if you had a circle. See if I can get my circle shape here. And if you were going to at that circle in the XY coordinate plane, or you were going to look at the distance all the way around the circle, then if you started at 0, then whatever this radius is, let's say it's radius 5, then if you complete a trip all the way around the circle, the distance around that circle would be 10 pi. That would be your arc length around the circle, but you would have to divide that by the radius. And so no matter how big or small the circle is, 1 complete revolution is equal to 2 pi radians. So now we can take a circle and we can put it in the coordinate plane, and we can think about if we were to rotate what our parameters would be. You would still start at 0, but if you made a complete revolution, you would end up at 2 pi. So half of that would take you to pi, half of that would take you to pi over 2, And then 3/4 of the way around would take you to 3 pi over 2. If you were going to look at this in terms of a decimal, in your parameters, we would just want to look at the decimal equivalency of pi. So a complete trip around the circle would be approximately 6.28. Half of that would be 3.14. Half of that is 1.57. And 3/4 of that would be 4.71. So look at this next problem. It says estimate the measure of the angle 3 different ways. So if I wanted to try to kind of figure out what this looked like, or just estimate, I might take the vertex of this angle and kind of put a little dotted line here and maybe extend it here. So look at this versus this and just kind of estimate. Probably the first one I might estimate might be degrees. So to me this looks like it's about halfway in between there. So maybe 135 degrees. If I wanted to look at that in terms of radians, I could either do it as a multiple of pi or as a decimal. So if I were doing it as a multiple of pi, I know that 90 degrees, or I know from here to here would be pi over 2, and this would be pi. So halfway between a half a pi and a whole pi would maybe be 3 pi over 4. If I wanted to look at it as a decimal, then I would have to kind of guess if this is 1.57 and this is 3.14, and I'm just doing an estimate, I would want to pick a number that's like halfway between those two. So maybe like, I don't know, 2.4. So radians can be as a multiple of pi, or it can be as a decimal form without the pi. Now, if you look back at the previous material and we merge these things together, notice that when we're doing it as a multiple in terms of pi, this here, that when we do a 180-degree rotation, that is equivalent to rotating pi radians. So we're going to skip forward and remember this fact, that pi is going to equal 180 degrees. So I just want to do a problem of each type, and then I'm going to turn you loose, and in class you're going to be given some different types of problems to work. If you were asked to convert 7 pi over 12 to a degree measure, in chemistry you do unit conversions by canceling out units. So this is a radian measure, and we want to convert it to degrees. And I would like to get rid of this pi, and I know that pi is equivalent to 180 degrees. So I'm really just taking 7 pi over 12 and multiplying it by 1. So if I do this, the pi's cancel, and I get 7 times 180 divided by 12. And if I work that out, I get about 105 degrees. If I want to go backwards and convert from degrees to radians, let's suppose I have something like 160 degrees, and I want to write it in terms of radians. I'm going to multiply by this time. I want the pi, and I want the degrees to cancel. So this is really just reducing the fraction 160 over 180. You might be able to do that in one step, or maybe it'll take you a couple of steps. I would probably think of it as 16 over 18 pi, and then realize that both of those are divisible by 2, and get finally 8 pi over 9. So you're going to have some problems in class. You're going to convert from degrees to radians. You're going to be thinking about radian measures and in which quadrants things terminate. So just be ready for that tomorrow.